Welcome to another edition of FLW's Instrument Talk podcast. Today's topic will be the measurement of CO2 in bioreactors or fermenters in the biopharmaceutical industry. Today, my guest is Dave Ferragamo. He is the Director of Sales for Mettler Toledo Process Analytics in the U.S., based in Billerica, Massachusetts. Welcome, Dave. Can you tell us a little bit about yourself?
Hey, Rob, good to be here. So I am the Director of Sales of Mettler Toledo Process Analytics. We focus on inline measurement and control of parameters such as pH, dissolved oxygen, dissolved CO2, conductivity, total organic carbon. I've been in sales management for Mettler Toledo for 19 years. I have about 31 years of practical experience with electrochemical sensors. Those are the types of sensors that we use for these types of measurement. I graduated from Suffolk University in Boston, Massachusetts, with a Bachelor of Science in Biology and a minor in Chemistry.
So can you tell us a little bit of background on CO2 as a metabolic indicator in bioreactors in the biopharmaceutical industry?
Sure. So DCO2 in this case, and D and that stands for dissolved CO2, in this case uses the Sevringhouse method of PCO2 measurement. Now the P in PCO2 stands for partial pressure of carbon dioxide. That's what is actually being measured by the sensor, and we're converting it into dissolved CO2. Now, this methodology isn't new. It's been used for over 70 years in virtually every hospital in the world, and you'll find it in a blood gas analyzer. Blood gas analyzer is sometimes called BGA for short, both in hospitals and in biopharmaceutical companies. It's like I said, it's been around for 70 years. It's time tested. Works very, very well. And the way the technology works is it's essentially an advanced pH sensor that's used in conjunction with a CO2 permeable membrane. The CO2 in the reactor, in the media itself, in the broth, actually passes through the membrane, dissolves into the membrane electrolyte, and the pH sensor on the inside measures that change in pH, and they correlate it to CO2, or in this case, dissolved CO2. Now, it's the same methodology that's used in blood gas analyzers in virtually every hospital in the world, and now we've implemented it in online measurement that's used in bioreactors.
So why would you need or want to measure dissolved CO2 in a bioreactor or fermenter?
So with aerobic organisms, or those organisms that are like humans that actually breathe oxygen and respire CO2, CO2 is actually part of the respiratory quotient that's output by beneficial organisms, in this case, that are being used to grow biologics in a vessel, in a biopharmaceutical facility. So much like with humans, pH, oxygen, or in this case, dissolved oxygen, and CO2, or in this case, dissolved CO2, are critical to cellular metabolism in the body. Too much CO2 in a reactor is toxic to cells and negatively impacts the yield of the product you're producing, much like too much CO2 has a negative impact on humans as well. There have been studies regarding control of dissolved CO2 in bioreactors and fermenters and papers that have shown that the yield of the run is actually negatively impacted when dissolved CO2 isn't properly controlled at optimal levels. Furthermore, these studies also show that the proper control of CO2 in the media generates a higher yield of the desired product. And at the end of the day, that's what it's all about. I mean, the goal of any bioreactor is to generate the product of interest in the highest quantity possible, and CO2 control, proper CO2 control in the broth, in the media, actually drives that goal.
Well, it sounds like dissolved CO2 is very important in the process. Why haven't scientists or other engineers measured it previously, either in situ or offline?
That's a good question, Rob, and really is a two-part answer. First, Mettler Toledo Process Analytics developed sterilizable dissolved CO2 sensor technology in the form of a digital Sevringhouse sensor just a few years ago. And that sensor has performed very well in the biotech market, both when it comes to accuracy and precision. We have many successful biotech companies in which dissolved CO2 is a critical control parameter in their process. Now, regarding why scientists don't measure CO2 as a standard operating procedure now, the answer is they do. In this sense, however, they're either measuring CO2 via an offline BGA, and remember BGA stands for blood gas analyzer, with a grab sample from the reactor, or they measure CO2 in the gas phase through the vent of the bioreactor, and the sample is piped to a mass spectrophotometer, and they're measuring CO2 that way. Both of these methods do not, however, provide true in situ measurement control like they currently use with pH and dissolved oxygen. Therefore, there's no real automated control of the bioreactor that can be considered a rapid response to change in CO2 measurement via grab samples or mass spec analysis. With Mettler Toledo, we actually give the user the opportunity to measure in the broth where the reactions are happening, and it allows them not only to measure CO2, but to control it as well, to make sure that they're not pumping in too much CO2 to be detrimental to the cells. And that's where we differ from the offline measurement of the BGA, blood gas analyzer, or through the vent in the gas phase going off to a mass spectrophotometer.
Wow, it sounds like the InPro5000i, the dissolved CO2 sensor by Mettler Toledo, would solve a lot of problems for customers and give them a much better look at their process directly in their broth. More information available to anyone that would want it. They can reach out to Mettler Toledo or FLW Southeast. Again, Dave, I thank you for being on the podcast. Have a great day.
Thanks, Rob. You too.